Hello everybody, and to begin with, the goal of my work is to create a system designed for converting wave energy into electrical energy using a buoy-type mechanism with pneumatic cells. At the beginning of the research, a list of tasks was formulated. To analyze the features of the mechanism for using the mechanical energy of waves used in similar projects and described in scientific literature. To analyze the types and physical characteristics of waves. To develop a system design and perform a theoretical evaluation of systems effectiveness based on it. Create an experimental prototype and conduct an experiment of the efficiency of electric energy generation due to wave energy. So, let's go directly to structure of our mechanism. There is a buoy that consists of a double-action generator, pneumatic cells located like polygon faces, and rigidly attached ballast to maintain a horizontal position, respecting the surface of water. The size of the system is only a few times larger than the dimensions of an ordinary buoy, therefore it will not be bulky or difficult to manufacture. Several such systems can be connected in batteries, which will increase efficiency while avoiding a huge number of problems. So, how does this work? We see a pneumatic cells. Wave takes section of pneumatic cells. It is compressed. As the air within it is compressed also, and it goes to our generator of double action, and mechanical works turns into an electric one. Really simple. Also, we have the second type of working. When the system encounters the wave that is much higher than its height. First, the wave compresses the pneumatic cells. The generator works in the first mode using compressed air. But then the wave continues to act on the pneumatic cell. They in turn change their position and act as a lever. The generator works in the second mode. Location and use. This buoy mechanism can also be used for scientific measurements, just like conventional buoys. The electric energy can be transported from node to node or used locally, for example to extract hydrogen. In this way, it can contribute to ocean research and the rational use of plant resources. So, we have to determine the efficiency of our mechanism. For that, we conduct an experiment using pneumatic cell, the model of pneumatic cell, air tube with a load, and water container. First, we calculate the dimensions of the model, then measure the area of upper face of pneumatic cell. Using the calculator, we calculate the wave energy of required height. Then we calculate the equivalent wave energy that will act on a pneumatic cell model. And then a convenient mass of water m, an initial height h are chosen that satisfy the following equation. Then a certain amount of water is poured out of the pneumatic cell. Pneumatic cell is compressed, the air pushes the weight. Really simple. Then the weight of mass m moves at delta h. Converted energy is calculated using the following formula, and now we can calculate the efficiency of the mechanism. This coefficient can be applied to mechanism of real dimension. After that, taking into account the efficiency of the generator, we calculate the amount of electricity that the system can produce depending on the type and height of the wave. Experimental model creation process. We see the model. I've also attached, as you see, the y-axis to measure the movement of the load. The experiment. Besides sandbags were used for the experiments, and the efficiency of the mechanical energy conversion is calculated according to the following formula. You can also see the graph of the efficiency. Conclusions. Based on the analysis of the scientific literature, the type of mechanisms that are the most promising for the generation of electricity due to the energy of the ocean waves was chosen. A concept and graphic model of a buoy-type system for converting wave energy has been created. An experimental plan has been developed to determine the effectiveness of key parts of the system. An experimental model of one of the parts of the mechanism was constructed. The efficiency of data for the calculation can be applied to real-size mechanism, and particularities and ways of using the system are defined. Thank you for your attention.